Okay, hello, and now welcome to your third math lesson for today. Hopefully everyone understands a little bit more now about the morning math for where you possibly went a little bit wrong. I suggest that you write down some notes, or maybe you already have, based upon what you didn't do quite right, because there's a very high probability, very high chance that some of those questions could be repeated on the Show What You Know on Monday. So it's very important that you've taken the opportunity from the morning math to then improve by the time that we get to the Show What You Know, and that's always the goal. Okay, so the other thing that I've asked of you is to, on our math page, from this Stretch Your Thinking from yesterday on page 101 of the workbook, I'm super curious to know your results. Okay, so Matha got 22 and then 78. Okay, cool. So I'd like you to do that, and then Fasty as well, even if you just post. Like you could do like EP for A, for example, equals, I don't know, 25 over 100, okay? And then EP for B equals 75 over 100, okay? I'm just gonna say that that's what I got. It's not what I got, but write in what you got. I'm super curious, okay? Yeah, because I'd actually hope that more people would have responded to this by now, the time that I'm doing this lesson, but that's okay. Please type it in, and then we'll talk more about it on Sunday, okay? Because hopefully a cool pattern will develop, but the more results that we have, the better. Okay, so today, this is our very, 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 very last thing that we're writing down. So I guess new page or whatever. June, I was gonna say July, June 11th, comparing probability. Okay, so I can compare experimental results with the theoretical probability for an experiment. So basically, we're combining the past 2 days now. So comparing experimental results, so what did you get? What actually happened? Like Matha got 22 and then 78. That's what she actually got in her experiment. And then how does that compare with the theoretical probability? So how does that compare with what we kind of expected to happen in the experiment? Okay, so you're only writing one little page today. That's it. If we were in class, we'd be more so having a class discussion about this, but that's okay. All right, so experimental probability. Okay, what do you notice? Okay, so think about this. What do you notice about the results? What do you notice about the results from that question from yesterday, from that question on Stretch Your Thinking? What do you notice about the results? Okay. Well, let's just look at this again. Okay, so here. Okay, 22 to 78. Now, this is very faint, but we remember the theoretical probability of getting an A was 1, 2, 3, 4. The theoretical probability of getting a B was 6, right? 1, 2, 3, 4, 5, 6. So we would expect that Matha's data is a little bit kind of like, we wouldn't really necessarily expect this, would we? But that's what she got. So we would kind of expect, if we're thinking of equivalent fractions here, 4 over 10 is equivalent to what over 100? Well, magic number is 10, right? So we'd expect there to be 40 A's, and then, rather than 6 out of 10, 60 out of 100, 60 B's. So that's what we kind of expect to happen. But is that what we noticed happening? Well, it's not quite what we noticed happening, but we did notice that there was way more B's, which makes sense, than A's, because that's what our theoretical probability told us. Okay, so, all right, so what do you notice about the results? Okay, so how did the results change the more trials that occurred? So this is what I'm really curious to see from your combined results of the entire class. Like, even if we could get like, well, I guess like 1,000 to 2,000 results would be super, super, super awesome to see. So what do you think would happen when there's more trials that occur? And then why do you think that this is the case? Okay, so I'm going to leave these as your thinking questions for now. Okay, so as we see more information coming up on the Edmodo page, what I'd like you to do is then yeah, is then like kind of take notice of that. Like, how are their results changing if we have more and more trials of people's results that are coming through? Why do you think this was the case? Okay, so we're going to talk about that a little bit more on Sunday. Now, the homework for today is this, okay? Textbook, page 278, questions 1 to 3 and 4, but you do not need to do E, okay? So 278 in the textbook, 1 to 3 and 4. So that is this, okay? 278. So here you go. They have given you an experiment, okay? For each experiment, state the possible outcomes. The spinner has 3 equal sections labeled here like this, okay? The pointer in the spinner. Okay, so just label the possible outcomes. This is pretty easy. Label the possible outcomes. Okay, easy. Next. Okay, Dave tosses a coin 20 times. Heads is shown 12 times. How many times did tails show? That's pretty simple. What fraction, okay, you can figure that out, are the results what you would expect? This is where we're actually thinking of this comparison. C, this is a really important one. Is this what we would expect? Yes or no? And then if he tosses it 100 times, what would you then expect? Okay, this is kind of related to the question of, with the spinner that we just talked about for the show what you know. Okay, next one. Okay, this is the actual results from this experiment. So it's kind of the same thing. The most important question here again is C. Were Avril's results or Avril's results what you would have expected? Explain. And then this next one, number 4, is really important. So I definitely would like you to think about this one. So it's done 100 times. What is the theoretical probability, okay, of this? And then, so predict how many times they should grab this. And then they tell you some results from what they actually got. And then you're thinking whether this makes sense or whether it doesn't make sense, kind of thing. Okay, so give this your best. This is kind of like, these questions are kind of just like thinking questions. And we're going to go over this more on Sunday. So please, please, please do write down your stuff. And then make sure, please, that you post on our page of what you got for that experiment question on page 101. If you haven't done it yet, then just please do it. It won't take you too long to do. Hopefully it's kind of fun. It's like kind of like a calming activity, just spinning the spinner. It's meant to be kind of fun, like a game. And then type in what you got for experimental probability. Okay, good job. And that is it for the weekend. That's it. Good job.